Hey, in this video I'm going to show a new feature that I've cooked up called observability or structured observability. Yeah, so you can see here we have some jobs the agent has done and like what triggered the job, and then we can drill down into it and see what happened in the job. So we can see what the agent is doing because when you have like a complex set of steps, it can be difficult to figure out what the agent has done and why. So this helps you dig into that and see what it was doing. And we can like drill right down into um, sort of the messages that were sent to the large language model and tools such as the action counter we can see here. Okay, so what I'm going to do now is I'm gonna delete this agent and I'm going to create a new one so we can go through the steps of creating an agent as well and setting it up and debugging it. So let's call this one gem because it uses the Gemma model from Google, or Gemma, don't really know how to pronounce that. So first of all, we'll just set it up with one connector to IRC because I've got an IRC server running locally. There should be, yeah, host Docker internal. That's where it's running. 6667. Nickname, we'll call it gem. Keep it consistent. Join the channel gem. Get it to respond to all messages so we don't have to type its name. Okay, let's create that agent. So that should now be running. You can see it's got a really fancy avatar just there that was generated for us. If you have a better GPU than me, then you can get a better image, I can assure you. Okay, current status, nothing's there. Okay, so if we go to our channel, let's join the right channel. Gem, what have we got here? Hello. Okay, so let's clear out the old messages. Hello. And then if we go here, we can see, yes, we've received a job. Hello. Can't see which connector it came in on yet, but I'll add that. So you can see there it says hello where I've typed in hello. And then currently it's, yeah, you can see now it's finished. It had to generate that message. Usually it's quicker than that. Let's try, why are you so slow today? You know, it should be quicker than this. And obviously it's not going to give me a proper response, but can always try asking anyway. Ah, increased demand. I doubt it's increased demand, it's just my private server. Okay, so we're getting responses out of it from IRC, and we can dig into these responses, chat completion requests. So this is like an OpenAI compatible chat completion request. We can see message content hello. So that's what I sent it. We can see which model we're using, which again is Google's model, which is quite a nice one. 12 billion parameters, and it works very well considering its size. This is just running on a cheap GPU I bought from Intel. And then we can see the response here that it's made, and a bunch of information. You got like some stuff about filtering, which you can ignore, and usage, how many prompt tokens there were, this kind of thing. And we'll see later on that this view can get very, very verbose and complicated. So what we can do is we can also copy that and put it into a proper text editor when it comes to that. And we can see that this decision observable is nested within a job. So a job is like the top level thing that comes in, and then within that we can have nested items. Okay, so now what we're going to do is we're going to add some actions to our agent. So we're going to add a Wikipedia action, because what I'm going to do is I'm going to ask it questions and let it use Wikipedia to look up those questions, so that it hopefully hallucinates less. So if we go back to our observability, so it shows us that the agent has restarted. Has to restart when we update the settings. Now if we go to IRC, yeah, it can also tells us here that it's restarted. So we can ask it a question like, what is the biggest pyramid in South America? Okay, and we'll see if we get a sensible response to this. What is the biggest pyramid in South America? So what's it doing? Okay. So now we can see that so I asked it this question, what is the biggest pyramid in South America? And it came back with a tool call saying, okay, query Wikipedia. So if we dig into this, we can look at the creation item, which contains the information I sent it, plus here we tell it what tools it has available. Again, this is just standard OpenAI API stuff. And then in the completion, we can see, okay, it made a choice to call this tool. Again, it has some summary information there. Okay, and then next we have an action, which is where we call the function. So we can see here that we've got function Wikipedia, which of course this information is already up here, but it's repeated here. Parameters. So we're going to actually search Wikipedia with biggest pyramid in South America, and it's the LLM that's decided to use this as a query. And then we've got the result of the action, which is this isn't the full result that Wikipedia returned. If we go to the completion, yeah, in the completion we have the full result, and you can see it's quite long. So again, this is why we have this this button here, so you can copy that. And then next, what have we got? Finally, we've got says decision, but it's actually the response it gave us, I believe. Yeah, okay. The largest pyramid in South America is there. Great. Okay, you're asking about the biggest pyramid in South America. This is a fascinating question. The biggest and most impressive pyramid in South America is Carol, located in Peru. Blah, blah, blah. Okay, and then yeah, it also it also gave us the tool call in the response. So that's something we can investigate at a different time. Good. Okay. So now let's make things a little bit more complicated for it. So let's imagine that every time we call the Wikipedia API, there's actually a cost associated with that, and we want to track how many times we call it. Or, we just want to keep some statistics. So we're going to use the counter action. Okay, going to add that as another tool. Close this. Okay, so agents restarted. So let's let's ask it, let's tell it, okay, you know what? Let's go back into the settings. What we're going to do is we're going to give it a system prompt to tell it, like, every time you check Wikipedia, every time you check Wikipedia, update a counter. Let's try and be a bit more exact. Increment a counter called wiki checks. Okay, so we're going to make this our system prompt so that it knows when we ask it a question and it uses Wikipedia, that it should update that counter. Okay, so it's restarted again. Hello. How many stars are there in our galaxy? Okay, let's go and see what it's going to do. Okay, so first of all, it's decided it's going to call the tool counter. So this decision doesn't really make a lot of sense if you look at it without any context, just saying, hello, how many stars are in the galaxy? Well, I'm going to update this tool called update this counter. But afterwards, okay, so we update the counter, and then afterwards we get created counter wiki checks with initial value 1. So the result of the tool is being fed back into the LLM, and then the LLM decides to call Wikipedia. So this is a bit strange. Again, if you don't have the context, it looks a bit odd, but what we can do is we can drill down into it and look at the creation. And we can see in the creation all the messages that the LLM will have received. And we can see that, yeah, it started off with a system message every time you check Wikipedia. Then we have my request, hello, how many stars are in the galaxy? And then we can see that it decides to update the counter, and then the tool comes back with created counter. And also we have the tools listed that it has access to. So that's what was fed into it, and once you have that bit of context, then it sort of makes a bit more sense that the next action is to do something that seems unrelated. So query the Wikipedia. Okay, so it gets some information from Wikipedia. Okay, and then eventually we have the what it outputs. 100 to 400 billion stars. Okay, and what we can do is we can quite often what will happen is the agent will make a tool call and return some information, but that information won't actually contain, the tool's return value won't actually contain the information that we want. I mean, I believe actually you can see in this sea of text here that it does actually contain the right information, but quite often the LLM will just hallucinate an answer. So it's important to be able to check, look at the results of the tool and check what information was actually returned. Okay, so that is it.